All right, so I'm Dustin Northrup, and I've been working on some yardings found in the Kainan Basin of Western China. We're doing a comparative analysis within this particular yarding field, and we'll talk in a few seconds about what a yarding is and where this is. And I'm sorry, I'm probably butchering the names, but we're looking and comparing the morphologies of them, and with an eventual goal, possibly looking to determine whether we see these features on other celestial bodies, such as perhaps Titan. So, okay, a yarding. So this is kind of the most concise definition that I like. And it's just a relatively straight, elongate ridge that forms as wind and other mechanisms erode sediment or rock. So we see these in China. We've seen that they can form in something as simple and soft as lake, ancient lake beds, soft sediments. But even there is some literature saying that they have seen them in crystalline basement rock. So these are kind of an interesting feature. They're not as well studied as many other aspects of geology. And so we're looking at these here, again, in the Kainan Basin. It's in western China. So, where's this? It's the middle that you said? So the Chinese border is kind of left roughly like right through here. The Taklamakan Desert is to the west, and the Kainan Basin sits roughly about here. It's ancient lake bed sediments, soft stuff. It's had north-south prevailing wind directions, east-west prevailing wind directions, and the Dunhuang Yardang field lies just to the north, right where that arrow points. And that's where we focused our work thus far. So the Yardang field itself, we kind of can split into two separate, I guess you could say, subfields, mini-fields, I don't know. And they're formed mainly in this erodible lake bed sediments. And they kind of have a blunt morphology. It's kind of hard to see here. The tops are kind of blunted along there from the wind. You'll be able to see it better in some other pictures. But you can see here we have our we call this the southern Yardang field, and this is the northern. It's all within the Dunhuang field itself, but we just split it that way. And it'll make sense why. And when Jenny was there, she actually saw that they had some kind of a gray limestone lag surrounding them. And this would form some ripples on the ground that you can then use to determine the wind direction, which is kind of a northeast, southwest direction. So our methods, what we did is, the first thing we did is we realized that there is significantly more yardings in the northern section of the fields. And so we split it into three separate fields. We have northern yarding field 1, 2, and 3. This was just to make for ease of measurements, making sure our tables just weren't overly massive. The southern yarding field down here we didn't split up too much, just because there's much fewer yardings in this area. Okay, so this project is currently ongoing. We've only had time to really look at northern yarding field section 1. In this field, there's 67 separate yardings that we've measured. We haven't completed all our measurements on them, and I'll tell you in the data sets when we show you some information which ones comprise all 67 and which ones are still needing more work, which we're still working on, in other words. But you can see here we have all 67 marked, and you can see a little bit here. We talked a little bit about a little bit more blunting. It kind of tapers down. Right there's a good example there. And it's hard to see in these ones because I have the lines on them, but they kind of have this blunting at the windward side, or at edge, I guess. So the first thing that I did is I went through and I measured their lengths. And I did this two separate ways. The first was just 2 points to just measure a straight length. So we basically, and we did this in arc, we just put a point here and a point at the base. We calculate the geometry, the length in meters. And then after that, what we'd do is I calculated the length of following the crest lines. You can see the crest lines of the yardings a little bit. It's hard here because they're covered by the lines. But we would use that to calculate the length, so we would just put points along each crest, and we would calculate the geometry again in ArcGIS. The point of these measurements was to eventually be able to calculate a sinuosity, which we'd be able to use eventually to compare with dunes in order to help understand the differences. Then we also wanted to calculate the spacing, and this was done from crest to crest. In this, I used 3 lines. And I tried to keep them as east-west as possible. And so we would just put a point on the crest line and go straight across to the next closest crest. And you can see we didn't calculate through between multiple yardings that were a couple yardings apart. Rather, we just chose the closest yarding to it for our spacing measurements. We also calculated, the edge-to-edge spacing as well as the widths. These calculations themselves here we have not completed. The lengths and the crest spacing we've done for all 67 of the first field in the northern section. But this one we've only got about 15 measurements just due to time constraints. So this is ongoing. And what we did is I just digitized around the edges of the yardings to give us kind of a reference frame as to where the lines were, and so I could also just in arc snap the width and the spacing measurements, just lines just to the edges themselves. Then in the green, I calculated the widths. And this, rather than just go directly east to west, we realized that many of our yardings are oriented they're a little off from north-south. And so I tried as best as I could to calculate or to draw my widths perpendicular to their crest axes to give us a better cross-sectional width of each yarding. As you can see here, this one is much more skewed from north-south than this one. For that reason, we kind of varied our angle a little bit on our width measurements. And then we also calculated the edge to edge to get kind of the inter-yarding spacing between edges. And we kind of just followed the same pattern we've been using with the crest-to-crest spacing with that. So our width, we found that we had an average of approximately 53.5 meters. This again is only for 15 yardings. We expect this to change. We still have, to finish the rest of the 67. And we saw a deviation of about 17 meters. And so this was our initial findings here on the width. I'm not going to talk too much about that. However, the length, this is for all 67. We saw the average is roughly 87, or 875, excuse me. And a nice distribution with mainly most of them being around both close to 440 or 1,100, and kind of fall within that range mainly. Our sinuosity, they're very straight. There's not much curving to these. So with an average of 1.007, with one being perfectly straight features. And so that's expected to be used in a key piece of information in understanding morphologies. Spacing, this is the spacing from crest to crest, so this encompasses all 67. We see the same trend as we saw with our sinuosity, with an average of approximately 85 meters in the spacing. So as we were looking and examining these yardings in GIS, there were a couple things we noticed in each section, each field. The northern yarding field, we saw obviously trends roughly north-south. It had a good variability in lengths. Over here, they're much shorter than the yardings over here. And then we had a low degree of sinuosity, as was already displayed, with moderate spacing in comparison to other yarding fields we've looked at, or just briefly examined the images. And then we've also noticed they're relatively continuous along their lengths in comparison with the southern field. And they have a high density, yarding density per area, especially right in here, where they're just packed together. Whereas the southern field, it has this kind of east-west trend, and it's pretty broken up. There's a lot of discontinuity between the material and lengths, particularly up right through here, a little bit in through here. They're just really broken up, and there's a low density of yardings per area. They're just really, really spaced apart. And so, oops. Here we go. So, we kind of came up with a story that we initially had prevailing winds running east to west, forming these yardings down here. This switched to north to south, forming these yardings. And we noticed that these yardings are much more broken up than these down here. And we believe that as the winds switched and began to form these yardings up here, it began to erode and break apart these yardings in the northern section of the southern field. And these yardings kind of acted as a barrier to protect the yardings in the more southern sections, and so they didn't experience as much erosion and weather. So again, this project still has a lot of work to be done. We need to finish the measurements on not only just the northern yarding field 1, but finish the entire set in the Dunhuang yarding province. We also want to look at the Lut Desert in Iran. These yardings right here, they're much larger on scale, and they look very different. And so in order to understand our yardings, we want to get a better look at that. We also want to compare it with dune morphologies in order to help us better understand if features that we see on, in this case, Titan or Venus that appear to be similar are dunes or are in themselves yardings. So, kind of conclusion, when we just saw the northern yarding field, high degree or a high yarding density per area, densely populated, they're fairly continuous. The southern field was much more broken up, much more discontinuous, not very high density. We attributed this to the changes in prevailing wind directions. And then we need to in order to continue and enlarge our understanding of yardings and morphologies, we need to finish our data sets. We need to look through some other yarding fields and compare them with dunes so that we can at last understand and differentiate between yardings and possible and dunes on other celestial bodies. Thank you.
Which features are you presuming could be potential yardings? Is it the
kind of these linear lines,
dark
just very straight. I kind of think that these might be yardings rather than.
Do the measurements, are there different measurements for dunes and there are for yardings? And that's why
Yeah, so that's one thing we really want to look at to better understand. I actually haven't looked at dunes yet. We just started this, literally within the last month or two. And so we're pretty preliminary, but we're hoping to see a difference.
The change in wind direction is, what's the timing of that? Are we talking, thousands of years, hundreds of thousands of years in between the formation of the one set versus the other set?
And that's the question. We haven't quite looked at that yet.
Do you think, is there any possibility there's a structural component for those things as well?
There may be. We've actually kind of wondered on a couple of, kind of not to diverge, but along the same lines, wondering if possible things that are forming these is maybe we're getting a layer or something that's causing a more resistant layer that everything kind of forms behind, if that kind of makes sense.
A joint pattern?
Yeah, something like that that's protecting it or helping it form. But we just don't know yet what I've done. Yeah.
What's the scale of the ones in China?
Yeah, so the scale of the ones in China, they range in lengths from basically 1 kilometer long to 9. There's a variation.
How deep into the?
Did you say you saw about 40 meters? Is that what it was?